Hello everyone, we'll continue in solving the puzzle of rectangle given by its diagonal. As you see here, this diagonal has length of 13 units, and from this special location there is 7 units to the vertex to the upper left, and we supposed to find the length of this red line segment. And so the first thing when we solve geometrical puzzle, we're supposed to look at it from different points of view. We can even rotate the object, the picture itself, and just search for something that is related to some basic ideas from geometry. So here's my version of a rotated image, and we see and uh, we can kind of recognize that the rotation was intentional to get as many numbers aligned here in this right angled triangle. So we have 5 units, 8 units, and eventually even 7 units. And we can start to draw all different right angled triangles into this image and use the fact that some of those triangles are similar. So here I show you the largest one. The hypotenuse has length 13, and we don't know the sides of the right angle triangle. So I will label them as A and B, and then we know that A squared plus B squared is 13 squared. I also show you here a little similar triangle at the top corner. I label it A prime, B prime. The reason is that the A prime is related through simple ratio to the big A. The B prime is related to the big B. Now, big meaning size-wise. So you see the B is the entire side of the big triangle, and B prime is the smaller one you see in pink. Okay, so let's write a couple similarity equations. Here we have all the different ratios. So A over 13, that you can also say that this is the one of the side of the triangle divided by the hypotenuse, and equally A prime divided by its hypotenuse 5. And so that's what I write here. We have also the small triangle over here on the right corner. And that one is having notation with double primes. So you see this A double prime over here is related to hypotenuse, as the big A is related to the total length of the big hypotenuse. So due to the fact that the angle is the same, we have similar triangles, and they are both right angle triangles. So even the complementary angle over here is the same. So we can create a lot of relationships, and the question is what we do with it. So let's move on. I will just copy all the results from the previous page, and we will look at the specific useful relationships that lead to the answer. So here, for that purpose, I would like to pay attention to this right angle triangle that I didn't use so far. This is different. That's not similar triangle to the big one that is 13 inches or 13 units long. And so this triangle is using the third number 7 for this hypotenuse that I didn't use so far. As you can see, we have the number 5 used, we have 8 and 13. So we used everything except the number 7, but the number 7 is linked to A prime and B prime, double prime. And so that is the connection link that leads to the final answer. So we substitute for A prime from the first relationship here, and we get this term. And then for B double prime, we use this term. So we are not using everything in the orange box. We are just using, you could say, diagonal terms here, and that's enough. Now we have equation that still has A and B in it. So let's simplify this expression. So we also know that from this yellow box that b squared is 13 squared minus a squared. So as you see, the 7 squared is related to a squared and b squared, and also 13 squared is related to a squared and b squared. There are two equations for two variables, and now we're supposed to just substitute for b and eliminate b from the equations and find a. So let's do that. And I think this doesn't need any comment. Here is the place where I substituted for the b. So this is the b. From here, you go to here. And then you continue and evaluate everything what has some numerical base length, square root of 65, and the other square root of 104. Those are preliminary results because the ultimate question in this puzzle is the length of the red line with the question mark over here. So I'm using again the results from the previous page, and here I just want to show you what will be used in the last step. So again, triangle, right? And this time we have a double prime that comes from this lower triangle, and we have b prime that comes from the upper left triangle. So we have those two sides. Again, they are inside this orange box related to the big A and small and big B, and those are already known values. So the x is easy to find from Pythagorean theorem. So I'm using all the numbers we know. I'm trying to avoid using calculator. I just like to play with the numbers, see what cancels out. For example, this 13 cancels out that 13, and we are just getting that x squared is 40. And then once we factorize the 4 out of the square root, we get 2 times square root of 10. Non-trivial result that is approximately equal to 6.32 units. You have to print this when you construct your results using maybe GeoGebra, as I suggest in other video, and then you can print it and measure using a ruler if those are the right numbers. And so to finish, I'll just add here that here if you would like to see what is this alpha, you can test if the number 5 and a and the x, if they are related by Pythagorean theorem. If they are, the alpha is 90 degrees. If they are not, we would have to use law of cosines, but in this case it really does work, and we can say that this alpha is 90 degrees. In the other video where I use vectors and dot product, it comes bit more naturally this observation, and I recommend to all of you to watch it. Thank you for your time, and see you later.